right, here's example number 4. This one might be about the most amount of work that you'll have on one of these. So here you see two radicals. They're not set, just equal to each other like example 2, where we could just raise the power and get rid of them. So here we actually have to isolate one of the radicals, right? That's the first step. And so probably the easiest one to isolate would be the positive one. So I'm just going to add the square root of 2x plus 1 to both sides. Oops. All right. And so we end up with the square root of 3x plus 1 equals 1 plus square root of 2x minus 1. Okay? So now we can square both sides. All right? Now, here's where it's a little tricky. This we know cancels out, and that's great. That's what we intended to do, is to get that radicand out of there. However, on the right side we have an issue, right? Because if we square both sides, if we square a binomial, remember we can't just square this and that's it, right? We actually have to expand it, right? We have to multiply 1 plus root 2x minus 1, and we'll talk about a shortcut here in a minute. Okay, so we actually have to expand that, right? We have to FOIL it or distribute, okay? And so we're going to end up with 1 times 1, which is 1, right? 1 times 2 or root 2x minus 1. Yeah, actually see that I messed that up here, right? It should be 2x minus 1. Okay. Anyway, 1 times root 2x minus 1 is root 2x minus 1. Root 2x minus 1 times 1 is root 2x minus 1. And then we finally have root 2x minus 1 times root 2x minus 1, right? And here, when we multiply a square root by itself, we do get the radicand, right? So we get 2x minus 1, okay? All right, so that's the result when we FOIL. Then we have some like terms, right? 1 minus 1, or 1 minus 1 is 0. Okay, so those cancel each other out. And then we have a 2x that doesn't have a like term, but these are like terms, right? So root 2x plus root 2x is 2 root 2x minus 1. And then we get plus 2x. Okay, so that's what that equals when we square it. So I'm going to put that over here. 2 root 2x minus 1 plus 2x, right? Okay, and so now I still have a radical, right? So kind of when you get to this point where you isolate a radical, square both sides, or raise both sides to a power, and you still have a radical, repeat the process. Okay, so kind of rinse, repeat, lather, rinse, repeat, or whatever it was. So I don't have hair, so I don't know about that one. So anyway, so now we're gonna isolate the radical, like we said. So I want to subtract 2x from both sides. So I get x plus 1 equals 2. There's 2 times the root of 2x minus 1. Now I could divide everything by 2, but I'm just going to keep that there because as long as it's a monomial radical expression, it's not a big deal. But if I divide by 2, I'm going to have fractions on this side, right? And I'm going to avoid that for now, at least. So I'm going to square both sides. So I isolated the radical. It's okay to have a coefficient there. And then I'll square both sides. So the square cancels out the square root. But I do have to square the 2, right? So it's going to be, just apply that there. So it's going to end up being 4 times the quantity of 2x minus 1, right? So the radicand came out, and then I had to square the coefficient outside. And then over on this side, now I have x plus 1 squared. So once again, that's something we have to FOIL, right? x plus 1 times x plus 1. And so that's going to be x squared plus x plus x plus 1, right? And when we combine like terms, we're going to get x squared plus 2x plus 1. Okay, and once again, we'll talk about some shortcuts in a little bit. So I get all that. I'm going to distribute the 4, so I get 8x minus 4. Alright, so then I'm going to add 4 to both sides and also subtract 8 from both sides, 8x. So we get x squared minus 6x plus 5 equals 0. And so we want to find numbers we can multiply to get 5, right? That we can add to get 6. So of course those are 5 and 1. So put x here. 5 and 1. Remember, this tells us the sign of the bigger number, so it's going to be a negative here. And then this one tells us if the signs are the same or different, right? Positive means the same. And so that means we're going to have the same as what we had in the other for the bigger number. Okay? All right, and so then we just switch our signs. X equals 5, x equals 1. All right, so now I have to check for extraneous. So I want to go way back to the original equation. So that's the one right there, right? So I want to see if I plug in 5, 3 times 5 plus 1 minus 2 times 5 minus 1, does that equal 1? Right, and so we're just checking here, does that equal 1? And so here we have 16 underneath, right, the radicand, so square root of 16 is 4. Here we have 10 minus 1 is 9, so this would be the square root of 9, which is 3, and 4 minus 3 does equal 1, right? So this one works. Now let's try the other one. So if I plug in 1, 3 times 1 plus 1, does the square root of that equal the square root of 2 times 1 minus 1? And does that all equal 1? So here we get the square root of 4, which is 2. And here we get the square root of 1, which is 1. 2 minus 1 does equal 1. Okay. All right, so here's a situation where we had 2 answers. And remember that sometimes with these you can have 2 answers. Sometimes you'll have only 1 answer that works, and sometimes you'll have both possibilities will be extraneous, in which case your answer will be no solution. Okay. All right. Hope you enjoyed this video, and you can hit me up on email or the Google Voice number if you have any questions. Okay, or bring them to class.